All right, the next thing we're going to go over is z-scores. We'll talk about standardization on a graph, and we'll calculate the correlation coefficient. Now, we just did standardization, so we've got our two standard deviations here, right? A z-score, we got to take the mean. Sorry, we take each piece of data, subtract the mean, and then divide by the standard deviation. Well, if you look over here, here is our data, subtract the mean. We have all of that. So that's the top part of our z-scores. We just have to take each of those values and divide by our standard deviation. So to make this a little clearer, I'm just going to make another row down here. Okay? And I'm going to call it z-scores. So I'm just going to copy our x minus x bar, all those values. I'm going to paste them below. Oh, let me just... Didn't quite work. Oh, I see.
Because of formulas?
That's because of the formulas in there. I can do this instead. This is equal to that guy there. So it gave it to me. And then I'm just going to copy and paste that. So all it said was... Sorry about that. I didn't realize that would happen. Control V. There we go.
Cool.
So those are all of our values. I don't want to zoom out too far. But I've just copied all of our values in there. Okay? All I said was... this guy is equal to that cell, and then I copy and pasted it because every time I go one lower, every time we go one lower, it just copies the cell below that. Okay?
Oh, okay.
All right, so we've done that. Now remember what we said was we've got to take all of these values and divide them by the z-score. So this is equal to the cell beside it divided by, now this is one where we need that cell not to change. So do you remember what we use?
The number sign.
Yeah, or dollar sign.
Oh yeah, dollar sign.
Right? Dollar sign, and that cell is at C23. So we go dollar sign C, dollar sign 23. And it's always going to divide by this. So these are our z-scores right there. That z-score is 0.55. So now I just copy and paste that all the way through. Boom, all the z-scores done for us. Okay? And now, just to draw a reference, I'm going to highlight these. Calories are really technically our, we'll do them in a light blue. Those are our x-axis. Okay? Those are all our z-scores for x. So I'm going to call this uppercase Z, lowercase x. In other words, those are z-scores for our x-axis. Okay, we've just done that. Now what I'm going to do is the same idea is our z-scores. Z-scores. And remember, we're going to find the z-scores for the y-axis this time. So again, I need to get the same cells from above. So I know it's got to be equal to G2. Oops, 2. So I just copied that cell. And now I'm just going to copy this formula. There we go. So that's all the information. Right? Remember the last one being 9.86. 9.86. So we know we've got the same cells. We're good. Now we have to take these values. And we have to divide them by what?
Divide them by the standard deviation.
Yep.
Oh my God.
So what value? How do I type that cell in?
Okay, so dollar sign.
Yep.
6. Oh, the cell number.
The letter first.
H22. Is that what it is?
H dollar sign
and
23.
22?
Yeah. Okay. And see how it highlights the cell? It lets us know that.
So we'll know anyway.
Yeah.
Okay.
Boom. There's our z-score. So Control C or copy. We paste this through. Control V. Boom. All of our z-scores. Okay.
That's so
Nice and easy because z-scores take a while themselves. And I'm just going to highlight these guys too in a little bit of a different color. We'll do it in a light red. Okay. So just so we have our colors correct, these are the z-scores for our y. And these are the z-scores for our x. Okay, so we have that information. Now, remember, in order to standardize something, what we technically do, or graph it, we write the z-score for the x and the z-score for the y, and that's a coordinate in itself.
Right.
Okay, so because these are coordinates, you know what I'm going to do? I'm going to put them beside each other. So in our standardized model, these are our new coordinates, what we've just highlighted there. So I'm going to say standardized in caps lock. Okay. Well, that was supposed to be in caps lock. What happened? Standardized. I think that's how you spell it. So standardized. And again, I'm just going to copy those values. So this equals B30. And I just want to copy them all out. Control C. So that 0 told me I went too far. Okay.
Oh.
So that's our standardized Z blue one. And this guy here is equal to, and the reason I'm doing it just for organization's sake, okay? You don't have to do it this way. Control C. Okay. There we go. Okay, so these are all of our X values, ZX, and these are all our Z scores for our Y values. Okay, so they're beside each other. So we have those two now. Now remember, when we go to, so that would be all of our coordinates. We would plot those on a graph. I'm sure actually I can probably go like this and
Plot a graph?
yeah, if I go to charts,
You do.
yeah, I could probably find something in here. Insert chart. Do they have scatter
I
plots?
think they do. Are those them? No, this is silver. Oh, there.
Mark scatter, right? Boom, and there's our
Wow.
standardized plot. So see how fast I
Cool.
was to standardize that?
Wow.
So we're just gonna move that to the side here.
Yeah.
Okay. That was much easier to do.
Mm-hmm.
So already, let's actually
And
take a
then
look at this. What kind of correlation does that look like it's going to become?
A negative?
Looks like it's probably going to have a negative correlation. So let's actually go to the correlation coefficient now. All right, so I did that charting fast. Now I'm using a higher version of Excel, so that chart was easy to go. But you can still do it on, and I think you might have this one at home anyways.
Okay.
Okay, sum of all these ZX's times the ZY's. Okay, so I got to multiply ZX times ZY. That's what that means. So I'm doing all the Z scores of X times all the Z scores of Y. So that's really easy. So I'm going to write it like ZX, I'm in caps lock, so ZX times, again, you don't have to title things, I'm just doing this for our sake. And really all this is equals that guy, and now times is this little asterisk, okay?
Oh,
Times
okay.
that cell. So those are the values there. That's the values of ZX times ZY. Same thing, I copy and paste, boom, multiplied them all for me.
Nice.
Really easy.
Okay.
And finally, but that's only the top part,
And
right?
then you're going to count. You're going to do the count.
Yeah,
right?
that's right. So I also want to, but I also have to sum them. Okay, that's the multiplication. So this means sum. So I actually have to find the sum of all these. So equals sum. Yeah, there's that one extra step in there.
What was that?
So we sum all those values. Boom, that gives us negative 13. Negative, right?
Yeah.
We know it's negative.
That's true.
And we got to divide by our total number. Now, it's technically all of the terms we divide by, because
Minus
n's
one.
minus 1.
Yeah.
So I can put that as in this equation. I'll go equals count. And see how count already shows up? I can already just go and click it. Count all of these guys.
Okay.
Okay. But at the very end of it, I needed to do what? Yeah. So
Right.
minus 1. And that makes sense because remember in all of our other count functions we had 20? It makes sense that it'd be 19. So I'm going to put a title here. Correlation coefficient is equal to. Well, we already know that the sum of all the values is this guy here, negative 13, and the n minus 1 is our 19. So my correlation coefficient is equal to that cell divided by 19. Negative 0.69. And that's what they found in the back.
Yes.
Okay. But by hand, the amount of work, right? In video form, it took, those are almost 20 minutes of video.